Hey guys, hope you're doing well. So we'll talk about sum and difference identities today, and right now you probably wondering what does that mean or what is that, but in very few minutes you will be pros at sum and difference identities. So talking about your note card again, this is your cheat sheet or your little formula sheet, and some rules governing it. Everything must be written in your handwriting, not someone else's handwriting. Only trig identities and formulas may be written on the note card, just identities and formulas, right? No explanations, no sentences or anything of that sort. You can use it on quizzes and tests for the rest of this chapter if number 1 and 2 are good on that note card. So I'll check it and make sure that you have those things there. You have to write small, because if you write big things, you run out of space to write some of the formulas that we'll be dealing with. There's going to be a lot of formulas. I want to say at least 30 formulas. A lot of them are on the first page of the page before the beginning of Unit 7. A lot of them are there, so see if you can fit all of those formulas on that note card. I think there's about 3 pages of formulas. Alright, just to remind ourselves before we start this, sum and difference identities is sine squared theta plus cosine squared theta is equal to 1. This is a popular one, a famous one. We're going to use this a lot, so please don't forget it. Also, don't forget the other ones that come with it. However, if you know the first one, it's easy to find the other ones, because to get this one, you just divide by cosine, and to get this one, you just divide everything by sine, as we saw earlier in yesterday's video. Still from this first one, I can subtract cosine from both sides and get an expression for sine alone, or I can subtract sine from both sides and get an expression for cosine alone. So you can do the same to these ones and these ones, and this one and this one as well. Subtract 1 from both sides so that you have an expression either for sine squared alone, cosine squared alone, tan squared alone, or cotangent and secant squared alone. So just a reminder that everything that you can do to an algebraic equation, any kind of arithmetic, you can do it to a normal equation. You can also do to a trigonometric equation. So if you look at this here, x squared minus 4 is the same thing as x squared minus 2 squared, and it's a difference of squares, so I can write it as x minus 2 into x plus 2. I can do that same thing to this trigonometric equation and write it as tan theta minus secant theta, or close brackets tan theta plus secant theta. When I'm teaching 8th grade and I'm teaching this idea, I just tell the kids to think of them as animals, right? Just cow squared minus cat squared is just cow minus cat, close brackets, cow plus cat. So yeah, anything you can do to a trig equation, you can do to an algebraic equation. I can add something to both sides of the equation. I can subtract something from both sides of the equation. I can multiply the equation by something. All of the things that you can do. I can divide both sides, I can square both sides. As long as you do it to both sides of the equation, then it remains valid and consistent. If you have something like tan plus cot, and you want to make them squared, right? You want them to appear as tan squared minus cotangent squared. What do I need to do? What do I need to multiply it by? Well, I just have to multiply that by its conjugate, which is tan theta minus cotangent theta, and I know that that will give me tan squared theta minus cotangent squared theta. So we're going to see how we're going to see some sum and difference identities that can be used with these trig functions. Now there's ways, there are proofs or derivations for these identities or these formulas. And if you're interested in knowing how it comes about that cosine of some angle A plus some angle B is equal to cosine A times cosine B minus sine A times sine B, if you're interested in knowing how that comes about, I'm going to post a separate video that you can watch and satisfy that curiosity. I know all of you are interested in knowing, so that's exciting stuff. But these are the sum and difference identities that we're going to use, and it's important that they're on your note card, because I don't expect any of you to memorize all of these, except if you're me, or except if you studied 20, I don't know how many years ago I studied, because we had to memorize all of this, so lucky you. So let's start with this one, the value of cosine 75. And the importance of these sum and difference identities is that they can help you break down something like this without using a calculator. Obviously, application today is minimal because everyone has a calculator, everyone can compute cosine of 75. But you know, back in the day when this mathematics was just invented and there was no calculators, people had to work this out by head. And I keep saying the application of this for you is training your brain to, you know, work through different things, work quickly through problems, through situations, and, you know, think of alternative methods to solving different problems, not just in math but in life as generally. So the cosine of 75, I can break down the 75. Sorry about, you know, the times I keep going off on tangents, but all is good. 75 can be broken down into many ways. I can say 75 is the same as 45 plus 30, right? 45 plus 30. Or I can say 75 is the same as 60 plus 15, right? Or I can say 75 is the same as what? 70 plus 5, 50 plus 25. So I can break it down into so many different things, but I want to break it down into angles that have common ratios, whose ratios I know are simple to get. So I can't say it's 50 plus 25. I mean, I can't say that, but it's not going to help me because 50 and 25 do not have common ratios or fraction ratios. Those would be decimals. Same as 60 and 15, you know, 15 can still be broken down into 30, 45 and 30, but still this won't help me because these are not common ratios. However, 45 and 30 are common ratios, and when I see that 75 is the same as 45 plus 30, I can come to this difference formula for cosine and say cosine, the sum formula for cosine, which says that if I have cosine of some angle alpha plus some angle beta, that's the same as cosine alpha times cosine beta minus sine alpha times sine beta. So the alpha is 45 and the beta is 30 degrees. So I'm just going to substitute those angles. I'll have cosine 45 times cosine 30 minus sine 35 times, sine 45 times sine 30. Now remember, cosine 45 is root 2 over 2. Cosine 30 is root 3 over 2. I hope you guys remember this from last semester. The sine of 45 is root 2 over 2, and the sine of 30 is simply a half. So when I simplify all these, I'll have root 6 over 4 minus root 2 over 4, which becomes root 6 minus root 2 all divided by 4. So I found the exact value of cosine 75 without using a calculator. And I know this is exact because it's not written as a decimal. Because if I wrote it as a decimal, I would, you know, there would be some error if I truncate some of the decimal places. So this is the exact value of cosine 75 degrees. I got it without using a calculator, and this is why these sum and different formulas are useful. Alright, find the exact value of sine 7 pi out of 12. I need to figure out what 7 pi out of 12 is, or even better, I need to figure out, because 7 pi out of 12 is an angle in the second quadrant. It's somewhere here, right? Because it's not 12 pi over 12. This is pi. 12 pi over 12 would be pi. So I'm just asking myself, what am I missing? 12 pi over 12, which is pi. How much do I need to make 7 pi over 12? How much from 7 pi over 12? I'm just subtracting these two to figure out what the acute angle is. So 12 minus 7 is 5. So that's 5 pi over 12. Now I know that the sine of 7 pi over 12, the sine of 7 pi over 12 must be the same as the sine of 5 pi over 12. So I'll try to find the sine of 5 pi over 12, but I need to first figure out what angle that 5 pi over 12 is. So I'm going to first change it to degrees, so I know what angle I'm dealing with. So 5 times 180 divided by 12 gives me 75 degrees. Wow. Alright, so if this is 75 degrees, then I'm trying to find the sine of 75 degrees, right? I know it's 75 degrees, and I know 75 degrees is the same as 45 plus 30, and I know that 45 is the same as pi over 4 plus pi over 6, right? Does that give me 7 pi over 12, 5 pi over 12? Let's see. LCM is 12, correct? Yeah. Okay, so sine pi over 4 plus pi over 6, I'm going to use the sum formula for sine, which is over here. Sine A plus B is the same as sine A times cosine B plus cosine A times sine B. So this will be, because this is my alpha and this is my beta, this will become sine pi over 4 times cosine pi over 6 plus cosine pi over 4 times sine pi over 6. Now I just need to substitute the values of those that I know. Sine pi over 4 is sine 45, which is root 2 over 2. Cosine pi over 6 is cosine 30, which is root 3 over 2. Plus cosine pi over 4 is cosine 45, still root 2 over 2. And sine 30 is 1 over 2. When I simplify these fractions, I have root 6 over 2 plus root 2 over 2, which gives me root 6 plus root 2 divided by 2. And I hope you can see that the values are very similar to what I had here. The only difference is the subtraction, right? And just reminding you, I hope you guys remember, this is just a side note, I hope you guys remember that the sine of 90 minus some angle theta is the same as the cosine of that angle theta, and the cosine of 90 minus some angle theta is the same as the sine of that angle theta. So since here this angle is 75 degrees, I could have just tried to find the cosine of 90 minus 75 degrees. But yeah, I won't take you there. This might just confuse us some more. We'll find another example where this can easily be applied. But this is another interesting idea that we talked about last semester, and I hope it's on your note cards. All right, we write sine of x plus pi over 11 pi over 6 in terms of sine x and cosine x. This is simply calling us to use the addition formula for sine, or the sum formula for sine. So sine alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. So I'm going to just apply that because this is my alpha and this is my beta. So this will be sine x cosine 11 pi over 6 plus cosine x sine 11 pi over 6. 11 pi over 6, I need to first figure out what that angle is. I should have done that first. 11 pi over 6, I know 12 pi over 6 would be 2 pi, right? And that would be here. That would be 2 pi. This would be 12 pi over 6. But now this here, the angle I have is 11 pi over 6. So 11 pi over 6, I'm trying to figure out how far off is it from 12 pi over 6. I hope you can see that that's just pi over 6, right? 12 minus 11 is 1, which is pi over 6. So I know that the acute angle that I'm looking for here is pi over 6, because this is 11 pi over 6. So the cosine of 11 pi over 6 will be the same as the cosine of pi over 6. However, the sine of 11 pi over 6 will still be the same in magnitude as the sine of 11 pi over 6, but it will be negative because it is in the fourth quadrant, and in the fourth quadrant sine is negative. So my expression becomes sine of x cosine pi over 6 plus cosine of x times, this is not minus, this is times, negative sine pi over 6. So cosine pi over 6 is the cosine of 30, which is the same thing as root 3 over 2. So that's root 3 over 2 sine x minus, because of this negative sign, sine pi over 6 is a half, so this is just a half cosine x. So now I can, factorize out the half and say this is half, open brackets, root 3 sine x minus cosine x. I have written it in terms of sine and cosine. Yeah. So I hope you see that. I think that the only hard part here was trying to convert this angle to radians and then trying to remember what the ratios are, which I trust that you guys remember from last semester. And you guys even have tricks for remembering them on your fingers, so that's cool. This is also something we did last semester, inverse trig functions. The inverse sine of a half has to give you an angle. If you're finding the inverse of a value, you have to get an angle. So you're asking yourself, which angle gives me a sine value of a half? Well, that angle is 30 degrees, or pi over 6. And which angle gives me a cosine value of a half? That angle is 60 degrees, or pi over 3. So what you're dealing with is you're trying to find the tan of pi over 6 minus pi over 3. This is a difference formula for tan, which is what we're going to use, that says tan alpha minus beta is equal to that big thing, tan alpha minus tan beta divided by 1 plus tan alpha tan beta, the product. So this is your alpha and that's your beta, and you're just simply going to substitute. So if I'm using that formula, the difference formula for tan, this is going to be tan alpha, but alpha is pi over 6, minus tan beta, and beta is pi over 3, divided by 1 plus tan alpha times tan beta. I hope we remember that the tan of 60 degrees is root 3, right? Root 3, tan of 60 is root 3, yes. And the tan of 30 degrees is root 3 over 3. Hope you guys remember that. All of this divided by 1 plus tan of 60 is root 3 times tan of, sorry, what am I doing? Sorry guys, I kept saying 60 instead of 30 and 30 instead of 60. Okay, this is 30. Tan of 30 is root 3 over 3. And tan of 60 is just root 3. And tan of 60 again, root 3 over 3 times tan of 30. Tan of 30 is root 3 over 3. And tan of 60 is just root 3. So this is now an arithmetics problem. I can simplify it. The numerator will be root 3 minus 3 root 3 divided by 3. And the denominator will be 3 plus root 3 squared. I hope you can see it's root 3 times root 3, which is root 3 squared, all divided by 3, right? It's now an arithmetic problem, so you can solve it any way you want. The numerator is 3 minus 3 root 3. So it's root 3 minus 3 root 3. So it's as if you're subtracting 1 cow minus 3 cows. You'll get negative 2 cows, right? Negative 2 root 3 divided by 3. Because of this division, I'm going to multiply and flip. And this initial numerator, which is now the denominator, was 3 plus root 3 squared. But root 3 squared is 3, and 3 plus 3 is just 6. So these 3's are going to cancel out, and then I'll reduce here by 2 once, and by 2 is 3. So I'll end up getting negative root 3 divided by 3. So I have simplified or found the exact value of this expression without using a calculator at all. You can try this on a calculator to see if you're right, but I'm pretty sure you'll find that this answer is the same. Alright, we can also use these formulas to prove identities. Let's try to see how that works out. So I have cosine of alpha minus beta divided by sine alpha times sine beta, and they want me to show that it's equal to this funny expression. Now, every time you see these expressions and they're asking you to prove identities, and I am not joking when I say this, I mean it from, the bottom of my brain or heart. Please don't look at the end product and be scared, right? Just look at what you've been given and start with what you know. And what you know is that the formulas are on your note card. So you just run to your note card and check what is the difference formula for cosine. Difference formula for cosine, A minus B, is simply cosine A cosine B plus sine A sine B, right? Did I get it right? Did I get it right? Or is it? Yeah, it's a plus. It's right here. Cosine A cosine B, so I also had to go and check my note card, but I still did have to memorize these when I was in school. So this is what the difference formula for cosine says, right? So I'm going to substitute for this whole thing in the place of my numerator. So instead of having that numerator there, I'll have cosine A cosine B plus sine A sine B. Now the other thing is simple, because they want me to divide that whole thing by sine A times sine B. Well, let's see. What does this become? I'm going to break the fraction, because I hope you remember that if I have 3 plus 5 over 2 is the same thing as 8 over 2, right? But someone else can also work it out as 3 over 2 plus 5 over 2, which gives you 1.5 plus 2.5, which still gives you 4, just like this one would have given you 4. So I'm going to break down that fraction in the second way and say this cosine A cosine B, I can write this expression as cosine A cosine B divided by this denominator sine A sine B plus sine A sine B divided by the same thing in the denominator sine A sine B, right? So I'm just splitting the fraction. And when you look at this split fraction, this numerator is the same as that denominator, so that's where your 1 comes from, because you have a 1 in the expression, so that's where it comes from. And then, you know, these here, where do they come from is, I look at the numerator, I have cosine A over sine A, and that can give me cotangent. So I can still break up this fraction as follows. And since it's multiplication, I can still do this, and no one will be in trouble for it. So cosine A divided by sine A is the same thing as cotangent A, and cosine B divided by sine B is the same thing as cotangent B. So then you have easily proven what they asked you to prove, and yeah, you're a happier person. So as you're doing your homework, these are some of the things you're going to be having to do. And as you do them, I don't want you to get frustrated about the fact that maybe these things are not applicable, but just try to appreciate how much exercise. It's as if your brain is doing push-ups, you know? Just appreciate how much your brain is benefiting from all these push-ups. Your brain is going to get, you know, all ripped and all of that. All right, bye.